Hi everyone, I'm Juno Chen, a pre-sales engineer from ZW You can call me Juno. Today, I'll show you ZW3D's core features and special capabilities through this injection molding machine. We'll cover part design, assembly design, 2D drawing, sheet metal design, weldment design, and structure analysis. The demo will take about 40 minutes, but please feel free to ask me anytime with questions or suggestions as we go along. Alright, let's talk about part design first. So, every machine design starts with its parts, right? Let's create a new part and jump into the part design environment. As you see, ZW3D's interface is similar to SolidWorks. We use the same basic workflow, sketching, then extruding or revolving to create the 3D model. Let's start by sketching. You can draw circles, lines, rectangles, or squares, whatever you need. Once you have done, just double-click the dimensions to modify them. This is dimension-driven modeling. You change the numbers and the model updates. Now, let's draw a rectangle. Next, we can use the power trim command to clean up any extra lines. Just drag your mouse over the lines you don't need, and they're gone. After that, we'll add the dimensions to lock everything in place. You might notice that this profile isn't symmetrical. Just select the lines and apply a symmetry constraint. It's okay now. We'll exit the sketch environment and use the extrude command to turn this 2D sketch into a 3D solid. And that's the steps of how we build models in ZW3D Sketch. It is quite similar to SolidWorks, right? Besides extrusion, you'll often need to use other commands like revolve in your designs. Let me show you how it works. Normally, you'd sketch a profile to do that, but here's a cool feature in ZW3D. You can copy and paste geometry directly from 2D CAD files. Let's do that. I'll just press Ctrl+C to copy from my CAD file. Then Ctrl+V to paste it into ZW3D. Now, the lines are in. I'll clean up any extra lines I don't need. But you'll notice these pasted lines don't have any constraints yet. Don't worry, ZW3D has an auto constraints feature for this. Just select all the lines, and it automatically adds dimensions and constraints for them. Want to modify something? Just double-click the dimension and adjust it. Once the sketch is ready, I'll exit the sketch environment and use the revolve command to turn this 2D profile into a 3D shape. And just like that, we've got a solid. Now, beyond the basic sketch and extrude or sketch and revolve workflows, we've also integrated some really handy features like SolidWorks. Let me show you a couple of my favorites. First up, mouse gestures. You can customize mouse movements to set your most used commands. It saves a lot of time. Next, check out our quick access toolbar. If I need to add a hole, I can just click here. Select the hole command. What's cool about our hole feature is how easy it is to place holes correctly. For example, I can just click on a key point, like the center of this face, set the diameter, and choose through all to make it a hole. After that, I can quickly add chamfers to smooth out the edges. I can just select the whole model, and ZW3D will apply chamfers to all the edges at once. You don't need to do them one by one. Very efficient, right? Okay, sometimes we might need to create holes in the areas without any key points. In that case, we can use a sketch to position them. Inside the sketch, all we need to do is draw a point and then add the dimensions. For example, it's 130 here. Once we exit the sketch, the hole will automatically be positioned using this. There are several types of holes you can create. You can just pick the type you need and set a dimension. For instance, I'll choose an M20 size. After that's done, We can use the pattern command to quickly create more holes. You just set the number, and once it's done, you'll see that 2 holes go outside the part's boundaries. No worries, we can simply exclude them using an option in the pattern command. So, instead of doing it in 2 separate steps like other software, we can generate all 6 holes at the same time with one pattern command. So, you can see that the part is completed. The modeling process we've gone through follows the same logic like solid rocks. Most of the time, it's just using common commands like sketch, extrude, revolve, hole and chamfer. Alright, once the part modeling is complete, the next step is to create a 2D drawing to add the dimensions and annotations. ZW3D supports an integrated drawing module. By default, it offers various templates, like ISO, JIS, and other standard templates. Of course, you can also customize your drawing templates to match your company's standards. For example, I've created a template for a customer, which includes both A2 and A3 sheet sizes. For this part, I'll use the A3 template to generate its drawing. Here, we can choose a bottom view and set a suitable scale. In addition to standard views and projection views, we can also generate sectional views. Once these views are created, features like centerlines and section lines are automatically generated. When dealing with complex parts, it's common to add an isometric view. ZW3D makes this convenient. You just select the isometric view, set the scale, and it's done. If the isometric view's orientation isn't ideal, you can use the Rotate View command within the 2D drawing environment to adjust it, just like rotating it in the 3D modeling environment. Once you've rotated it to the desired orientation, just confirm that is okay. And if I want to show hidden lines in this view, I can easily toggle them on. After defining the views, we can start adding dimensions. For instance, you can select edges to create dimensions. For arcs, you can dimension the radius or diameter. And for lines, you can add the dimensions by selecting 2 lines. If you select a line of a hole, the software will automatically add a diameter symbol in front of the value. If the hole requires a fit tolerance, you can simply double-click the dimension. You'll see options like XXH7. By selecting H7, the system automatically calculates and applies the upper and lower tolerance values based on the basic size. No need to manually look it up in a mechanical handbook. Next, we can add surface roughness symbols. ZW3D fully supports annotations for roughness and geometric tolerances. For example, you can set a datum here. And select a feature, set parallelism at 0.012 regarding datum A, and it's done. For holes, there's a hole callout command. By selecting a view in the hole, all the hole's features will be annotated automatically, such as the quantity, simple hole diameter, counter hole diameter, and depth. This saves you from annotating each feature step by step. When creating a drawing template, it's common to include standard technical requirements outside the drawing frame. If you need one of these notes, just drag it into the drawing. If edits are required, double-click to modify them. With this, the drawing is complete. Once the drawing is ready, you might need to export it as a PDF or DWG file. ZW3D makes this easy. For example, if we want to export a DWG file, we can choose the DWG version during export. This is useful because the customer or supplier might not have the latest version of CAD software. By selecting an older version like 2004 or 2007, we ensure compatibility with older CAD software. Now that I've exported the DWG file to the desktop, let me open it in ZWCAD to show you. The colors remain consistent with the 2D drawing, and the layers are exported together. You can use layer toggles to show or hide objects. And that's the workflow from ZW3D to DWG. Just now, we saw the process of designing a part in ZW3D. But what if you need to create a series of parts or build a standard parts library for your company? ZW3D offers a quick way to handle this. For example, let's take a part where the diameter and height often need to change, resulting in different series of configurations. Similar to SolidWorks, ZW3D has a config table feature. Here, we can include dimensions that frequently change in the table, such as the diameter and height. What's more, ZW3D integrates with Excel to make editing multiple configurations faster. For instance, the current diameter is set to 300. If we want to add other configurations, we can enter diameters like 325 and 350. For the height, the current value is 180, but we also want a shorter one at 150. With these 3 diameters and 2 heights, we get 3 times 2 is equal to 6 combinations. After saving the table, once that's done, we can even assign different colors to each configuration for better visualization. For example, after setting the colors, you just need to double-click a configuration, and it will switch to that specific size and color. This configuration tool is a great way to quickly generate various sizes or standard parts for your company. Once the part design is finished, the next step is to position it in the assembly. For example, let's open a subassembly here and insert the part we just designed. After inserting it, we can use positioning methods similar to SolidWorks. For instance, if you select 2 cylindrical surfaces, it will automatically suggest the best concentric constraint. If the direction is reversed, just click here to change it. Next, select 2 planes like these 2, and it will suggest the best coincident constraint. Finally, by selecting 2 cylindrical surfaces and locking all degrees of freedom, we complete the constraint operation. These are the standard methods for constraining the parts we designed. For standard parts, ZW3D offers an even more convenient way to apply constraints. ZW3D includes a standard part library in the standard version. It supports various standards like ISO, GB, and others. It is similar to SolidWorks Toolbox. You'll find commonly used parts such as spring washers, screws, nuts, bolts, and bearings in this library. Just double-click a part to insert it. For example, let's choose a screw with size M20. The length is 180. Now, for standard parts, we have a quick way to apply constraints using the Auto Hole Match option. By selecting a surface, the software automatically detects all the interfaces where screws need to be installed and positions them with the necessary constraints. You can see here that the concentric and coincident constraints were automatically generated. If the standard part library doesn't meet your needs, after the assembly is complete, you can easily adjust the assembly size by switching between configurations. And if the part dimensions change, the screws will automatically adjust their positioning accordingly. ZW3D also supports third-party libraries like Misumi, Part Solutions, and TraceParts, which are widely recognized all over the world. Next, we will conduct an interference check to identify overlapping parts within the assembly. Any areas of interference will be highlighted in red, making them easy to spot. Another feature to show is the exploded view. ZW3D provides an auto-explode command. Simply select all the parts, choose a direction, and set a distance, 100. It will automatically explode the parts along the x-axis. Once completed, you'll find the explosion steps recorded in the history tree on the left. You can adjust the explosion sequence by dragging the steps, just like editing a part's modeling history. Usually, customers use a combination of auto-explode and manual adjustments to create the exploded view to show how the product is assembled. Now, you can use the explode via animation command to show the assembly sequence. Finally, this animation can be exported as a video file, making it easy to share with non-technical teams for review. After we've completed the product design, we can add dimensions directly in ZW3D's 3D environment using PMI. For example, we can quickly add key dimensions, like the distance between these two components or the diameter of this shaft, all within the 3D environment. Once the annotations and design are done, we can export the model in various formats for colleagues in non-design departments to view. Common intermediate formats like IGS or STP are often used, and sometimes 3D PDFs as well. ZW3D is distinguished by its unique capability to export models in HTML format. Let me show you how this works. I'll export this assembly as an HTML file. Once exported, the file can be opened directly using any browser, like the default browser of Windows, or popular ones like Google Chrome or Firefox. In the browser, you can rotate, zoom, and pan with the model easily. It also includes many useful features. For example, you can view the 3D PMI we just added. The assembly structure is displayed here, where you can show or hide components. There's an auto-explosion feature. You can create section views, measure dimensions, or even disassemble the model to take a look at the individual parts. This functionality is especially useful for the production department. Often, workers may find 2D drawings difficult to understand. With this HTML file, they can open it on their mobile phones for a clearer 3D view. You can share the file through instant messaging apps, Skype, Line, or anything else. Once shared, the recipient can simply open the HTML file in their mobile phone's browser and view the 3D model directly. This is a great advantage for companies aiming for paperless production. Some clients may also use 3D PDFs, but they come with limitations. Viewing 3D PDFs requires Adobe's professional version, which needs additional costs. Moreover, if you send an intermediate format to someone else, they'll also need the appropriate software to view it. That is a trouble. Sharing an HTML file removes these barriers, allowing the recipient to access it without needing to install any specialized software. They can use a free browser to view the model. This is a significant advantage. Now, let's return to the software. Once the assembly is complete, the next step is to generate the BOM. ZW3D provides two methods for this. 1. Generating a 3D BOM directly in the 3D environment. The benefit of a 3D BOM is that it allows batch editing of part properties within the assembly. For example, when I select a part, it highlights both in the BOM table and in the 3D workspace, making it easy to identify which part we're working on. If I want to update the material for these three parts, I can select them in the table and batch change their material to 304. The update applies to all selected parts. You can also customize the table headers. For example, if there's a column you don't need, you can remove it. Or, if you need additional columns, you can add them by checking this option. Another commonly used method is the manual input of part properties directly in the BOM. For some standardized properties, you can create a drop-down list for easy selection. If the properties follow a pattern like sequential numbering, e.g., 01, 02, 03, etc., ZW3D allows Excel integration to speed up the process. Click this button to open the BOM cell. You can use its autofill functionality to quickly extend the numbering or update other fields, like setting the supplier to Misumi for all rows by double-clicking. Once you've edited everything in Excel, just save the file, and all the updated information is synced back into the 3D BOM in ZW3D. Finally, when you confirm the changes, these properties are automatically applied to the parts. For instance, the Part 1 designed before has its updated attributes, such as its number and supplier, already filled in. This is one of the major advantages of the 3D BOM in ZW3D. It can modify the part attributes in batches. Of course, if you prefer generating a BOM 2D drawing, let's select a larger size here. In addition to the standard views, we can also add an isometric view or even create an exploded view. You can easily adjust the scale here to fit your needs. Next, we can use the auto balloon feature to assign part numbers to each component. After that, we generate the BOM. One standout feature of our BOM is that there is a legend property in it. Let me generate it to show you. Once it's ready, you'll see an image displayed in the corresponding row for each part. And when you hold your mouse over it, the image enlarges automatically. If you need to edit a part, just right-click on it, and you can make changes directly. We also support exporting the BOM to Excel format. When exporting to Excel, all the information is included, including the images. Some customers specifically require this feature. They need each part's image included in the BOM. This is helpful for the purchasing team, as they might struggle to recognize a part by its name alone. With this feature, non-technical colleagues can better understand the BOM, identify parts easily. Now, this is the traditional method of creating drawings. But in the latest versions of ZW3D, we have an auto-drafting feature. This feature can generate all the 2D drawings for the assembly, sub-assemblies, and parts in one operation. First, I'll set a path for the drawing saving. Then, we can select a uniform template. Next, we define the views to include. For example, I'll remove the right view and only toggle the left view. We can even apply auto dimensions, like adding the maximum dimensions. Once everything is set, we just click OK, and the software generates all the part drawings automatically, including their properties mapped directly into the title blocks. This saves lots of time and also ensures consistency. The generated drawings are saved in this folder. Let's take a look. Here, we have 16 files, all completed in under 10 seconds. Impressive, right? Additionally, after the drawings are generated and annotated, we can use the multi-export feature. For example, if we need to export the drawings as PDF or DWG files, or both, we can select all the drawings. Specify the formats, and click OK. It will batch export all 16 drawings into the selected formats. This feature is especially useful for sharing files with suppliers or sending them to other departments. It significantly reduces the time spent on non-design tasks. These are the features for assemblies and 2D drawings. Now, during the design process, we often receive models from customers or suppliers. ZW3D is very strong in terms of compatibility with different formats. As you can see here, these are the formats that ZW3D directly supports opening. For example, some popular 3D software formats like SolidWorks, Solid Edge, NX, Creo, and CATIA can open directly without needing to convert to an intermediate format. Of course, we also support intermediate formats like STP and IGS, no problem there. When I received a SolidWorks model from a client, we can insert it directly into the assembly. I'll find the SolidWorks file and double-click to insert it into the assembly environment. Once inserted, we can use constraints to position it. For example, we can align this face with that face and make these cylindrical faces concentric. Now, once the constraint is applied, we notice that the external component doesn't quite match the size of the rack. But at this point, we can't modify the rack itself because it's already been made. What we need to adjust now is this external component. Since it's from another software, it doesn't have the modeling history. But no worries, whether it's a SolidWorks, Creo, NX file, or an IGS or STP format, ZW3D gives us the option to directly edit these files. For example, using the DE Move feature, we can select the faces and drag them over. I drag it by 10 millimeters. Similarly, we can drag the other side. This command allows us to make changes to the part without needing parametric data. For holes like these, we have a special command to edit them. You can select multiple holes and make modifications. We can even adjust things like the radius, setting a uniform radius of 8 millimeters. No problem. Or, we could double-click a face to add some thickness. Another example, if we think this part is too long, we can simply drag it to shorten it. Once we've made our changes, we can go back to the top assembly. And you'll see that the model does not fit. All we need to do is click Rebuild, and it'll update the size and match the external component. This is how ZW3D handles importing and editing external components. It is a non-parametric editing method. And it is also a quick and flexible process that saves a lot of time. In addition to the common solid modeling and assembly features, we also encounter other modules like sheet metal design and weldment design. Let's open an example of an assembly where I want to design a sheet metal part. ZW3D not only offers bottom-up design but also supports top-down design. For example, if the framework of the entire model is already complete, we can insert an empty part into this assembly. Once we insert the empty part, the advantage is that we can refer to the existing assembly to model within this part. For this sheet metal, we can define its size by selecting 2 points at the 2 corners and creating a rectangle profile. After that, we can hide the assembly and use the sheet metal command to generate the panel. The thickness is 1 millimeter. And we'll use the flange command to select 4 edges. We can then adjust the corner radius, length, and other dimensions. If the corners aren't merged, we have the option to toggle it and automatically merge the corners. After completing the first flange, we can move to the second layer. Here, it will automatically avoid any interference between parts. This is a basic flange function, which is similar to what you'd do in SolidWorks. But besides the flange features, ZW3D also stands out with stamping features. For example, we need to create a louver or a dimple. For the louver, we can simply define its size and position with one line in the sketch. For instance, after drawing the line, we set the louver length to 100 millimeters, and then use the louver command. We can flip the direction, adjust the width and height parameters, and add fillets, no problem. Once done, we can use the pattern command to quickly generate additional louvers. Let's say we set the spacing to 50 millimeters and quantity to 10. And it will automatically create a symmetric pattern in the other direction too. It's a quick way to make louvers. Now, this rack also needs a water pipe outlet. We can use the dimple command to create it. Just like before, we start with a circle in the sketch, and after defining the size, we can quickly adjust it. Using the dimple command, we can generate the corresponding shape. There are various options here, like generating an open hole or flipping the direction and setting a distance. And that's it. At this point, the sheet metal door panel are complete. What we just talked about are the weldment components. For this, you can use ZW3D's weldment module to complete the design. Typically, in SolidWorks, you'd start by using a 3D sketch to create the framework for the rack. ZW3D supports this as well, but in addition, we also offer a quick generation command called 3D wireframe. With this feature, we can select the 3D wireframe and drag it to create the main structure first. Then, for example, we can set the length, width, and height. Or even divide the length into 3 sections using the quantity setting. Once the 3D framework is ready, we can use structural profiles to quickly generate the rack. In ZW3D, we provide different standards, including GB, ISO, and JIS, as well as aluminum profiles. You can directly call any of them. For this example, we'll use a square section. Let's choose a size, 100 mm * 100 mm. After selecting it, we can simply select the top line of the frame. For the angled sections, we can tick the Joint option and it will automatically join the pieces together. The same process applies for other sections, like the lower part, where we can quickly select the lines and finish the modeling. For the middle part, we just repeat the process. After this, we can use the cutting tool to remove any interference. By this point, the main framework is already done. However, if we compare it to this frame, we notice that 2 beams are missing. No worries, we can just select and delete them easily. Also, for parts with rectangular sections, we can use the Edit function. Select the pieces to modify. Choose the new section type, like a square, and enter the desired dimensions, 200 mm, * 100 mm. Once confirmed, it will quickly update the parts. Now that the rack is complete, we can move on to other components. ZW3D has a rich set of features for this. For example, if we need to create a support plate, we can select these 2 faces, it will automatically generate the plate in the center. You can adjust the thickness with the provided parameters. For other components, you can easily use pattern or mirror features to finish them up. Once the structural components are done, we can also use the structural BOM to quickly generate purchase BOM and cutting BOM. Meeting the different departments' needs for the manufacturing process. These are the features ZW3D provides for structural design. Once all the parts and the product design are complete, we can use the mouse to drag and watch its actual movement. Of course, if you need a more advanced level of simulation, ZW3D also offers an animation feature that can show the entire product's movement process. For example, here's the locking mechanism of an injection molding machine. In addition to manually dragging to observe the locking motion, we can also use the animation feature to display the movement as an animation. Our client has already prepared an animation. And during playback, if any interference occurs, the animation will stop automatically. The first time the animation loads, it may take a moment, but once it's done, you'll be able to see how the locking mechanism moves. Except for these linear movements, the rotation of gears can also be simulated through the animation. Now that the animation has finished loading, we can see the translation of the mechanism and also the gear meshing motion. All simulated using ZW3D's animation capabilities. This is the animation feature in ZW3D. Once all product design is complete, if you're concerned about the product's stress analysis, ZW3D can also meet this need. We've integrated a structure analysis module, which is similar to SolidWorks simulation module. For example, take this locking mechanism part. It might be applied locking force, but we're not sure whether this force could cause damage or not. In such cases, we can use the simulation module to validate it. Common structural analysis, like linear analysis, modal analysis, thermal analysis, and fatigue analysis, can all be found here. The process is very similar to SolidWorks simulation. First, assign materials to the part. Then set the constraint, like fixing a part in place. Afterward, apply the force, such as a locking force of 20,000 in pressing from this side. Once all these settings are done, we can mesh the model. The meshing process is simple, just adjust the mesh density. And we can directly submit it for calculation to get the simulation results. These results will show the total displacement, stress, and strain. You can also view the results in different formats, and even simulate the motion with an animated view of the process. After completing the simulation, we can automatically generate a report. We can publish it directly to the desktop, and with just a click, it will generate the report based on our template, detailing the part's stress situation and the materials here. This is an overview of the common and unique features of ZW3D used for designing this injection molding machine, including parts, assemblies, 2D drawings, sheet metal, weldments, and structural analysis. If anyone has any questions about today's demo, or if there are any features you use frequently in your daily work that I haven't covered, please feel free to tell me.